Okay, welcome back for the second video in the chem2 set. In the last video I was going over the calibration object screen you see in front of you. The last part of the screen to go over is the actual hex data from the table. And again, just to give a bit of information on how the tables are laid out. Or at least the 8-bit tables. The 16-bit fuel tables don't follow this format. The 8-bit tables all have the first byte is the number of entries in the table in hex. So this table, this advanced from map cold table, would have 3 entries. The first entry, the compare point on the x-axis is 3e in hex. The return is F4, so that means that anything less than 3e in hex would have a return value of F4. And the last part is the slope between the first point and the second point, which is O1 over D5. And then the second point is laid out the same way. And the third point is just a point because the slope is flat after the third point, meaning that any value requested of this table greater than 7a in hex is always going to return Fe, much like any value less than 3e in hex is going to return F4. And you can see that graphically from the table behind me, or behind the screen. It's flat at the beginning here, and flat at the end here. The 16-bit fueling tables all have a slope at the end, which at some point I'll show you. I think that is about it. You can also judge that these points in the table here, if you assume that this is actually at 3e, the distance between the x values, the 3e and the 4a, is much less than the distance between these two values, the 4a and the 7a, which you can sort of see here. That distance is much less than this distance. So the two basic types of data are tables and constants that you can edit with chem. Unfortunately, chem does not allow you at the current moment to edit bit flags like the config constant that the turbinator cals use. And let me just. This is a example of the max vehicle speed constant, and you can see here that this calibration object really doesn't have much data. It's just a single value for the constant. And again, you have all the same options, although some of them don't make much sense with the constants. Now I'll go over the x and y axis for a table here really quickly. Again, the x-axis is always the input, so the input is what goes across left to right, and the output is the y-axis, and that goes up and down. So basically this table is saying that whenever the map pressure vacuum is below, this is saying 4.02, and if you look off over here, the mouse cursor will show the x and y value. The x value is first and the y value is second. So whenever the map pressure is less than -4 psi, which is about 8 inches of mercury, there will be 6 degrees of advance removed from the spark calculations, and that comes up as the map pressure comes closer to atmosphere, and then kind of scales back off as it gets into boost. And again, there's certain tables are only used at certain times, and this is advanced from map cold. So if you wanted to know when this table would be used, down here in the description it says the curve is used when engine is below TMP SWP, which I think is probably like 150 degrees or something. So basically, when the computer uses this table, it goes and it knows what the x value is. So it supplies the x value to the table and gets back the y value. So usually, when you want to adjust a point in a table, you need to know along which axis you need to adjust it. And again, these tables, you can edit them by either clicking on these points and usually dragging. I must have something wrong here. Or you can click the points and use the arrow keys left and right to edit the x-axis, up and down to edit the y-axis, and I believe tab moves to the next point, so you can go back and forth with tab. And for this cal, I am going to make some changes to this table so that we can come back and do a compare with it. Oh, and if you hold down Shift and hit the arrow keys in Chem, it moves the point like 10 times or 5 times what one up or down arrow key would move it. So I'm just going to go and I'm going to say save, and this calibration is now saved with the update I made. And if I wanted to use this update, I would go and burn the bin file that I just edited, which is this one, I believe. Oh, no, this one. And go ahead and burn it to a chip. And there we go. The write button, actually, there's a difference between save and write. Save will flush the file to disk at some point in the future. Write will write it immediately, and that's more appropriate for the date stamp. Now to do a comparison in Chem, I just want to say open comparison, and I made an original copy of this cal before I went in there and messed with it. Oh, let me close the comparison, because what I didn't do is I didn't change this. So we got a good example here of how this first line or second line in this calx file is still pointing to the same binary, which I forgot to change earlier. So that should be enough. Save that. And we'll open the comparison. Oops, not the comparison, not the open comparison. And now, if I did everything right, it should show me the original curve. Yes. So now you can see the original advance from map cold curve in gray.